So in this video, I'm going to solve the question I have on the screen, which says that a skier uses a tar rope as shown to reach the top of a sky hill. If the skier is of mass 68.3 kg, if the snow-covered slope can be considered frictionless, and if the portion of the tar rope behind the skier is slack, determine the force required in the tar rope to pull the skier at constant velocity. So you have to determine the force in the what in the tar rope, okay, which will cause the skier to be what to move at a constant velocity. Okay, so what this means is that at constant velocity, acceleration equals what? Zero. Okay, so what that means is that force will also be equal to what? Zero, because force equals what? The mass times what? Acceleration. So if acceleration equals zero, then you get force equals what? Mass times what? Zero, which will give us the force to be equal to what? Zero. So what this means is that at a constant velocity, acceleration equals zero, and then force is also what? Equal to zero, telling us that what the object will then be what? In equilibrium. So if that's the case, then you have to find what the force in the tar rope, okay, which will cause this skier to be in what? In equilibrium. And at equilibrium, the sum of the forces in the x direction and the sum of the forces in the y direction all sum up to what? Zero. So you are going to look for these forces. Okay. Alright, so for this to be easy for us, we are going to represent this figure here on a free body diagram. Okay, so that's what I have here. And in free body diagrams, we can consider the object, okay, as what? As a particle. So we can consider this skier here as a particle. So that's why we have what this point A here, and then we consider the forces acting on the skier, which is the weight force, the tension force, and then the normal force. Okay, so one thing you should know is that the normal force always acts perpendicular to the plane. Okay, that's it acts at an angle 90 degrees to the plane. Okay, and then the weight force always acts in the negative y-axis direction. Okay, because it is pointing down, so it acts in the negative y-axis direction. And also the tension. For us to know the direction of the tension, let's assume that this guy here has left the rope. Okay, he's no more holding the rope, and then let's look at the direction that he will fall towards. You see that the sky will fall backwards. This tells that what the tension in the rope is what pulling it forward, so the tension will move in this direction. That's how can we have this direction here. Okay, so now we have presented this figure here with a free body diagram here. Okay, so what you are going to do is that you are going to sum all the forces acting on this guy and then equate it to zero, and then that will help us to find what the missing values here. Okay, so first of all, we consider the weight. Weight equals what? Mass times what? The acceleration due to what? Gravity. In this case, we've been given the mass to be 68.3, so the weight will be equal to what? 68.3 times what? Acceleration due to what? Gravity. So that's what? 9.8. So let's see the value you get for the weight. So that's 68.3 times 9.8. So that gave me 669. So the weight is 669.34. Okay, so let's make this 670 approximately. Okay, so 670 newtons. So that's the weight. Okay, so we know that the weight is equal to 670. So I'm going to write this here. The weight equals 670 newton. Okay. Alright, so now that we found the weight, we have to find the other forces too. Okay, so we have the tension and then the normal force. We are going to consider the tension force here. Okay, so the tension force here, you see that it makes an angle of what? 15 degrees with this horizontal here. Okay, this is because when you consider this diagram here, let's say I draw a straight line here. Okay, you see that for this we have what? A z angle here, something like this here. So this angle here will also be what? 15 degrees as this 15 up here. That's how kind of got the angle that the tension makes with what? This horizontal height will also what? 15. They alternate. Okay, so the angle here will also be what? 15. And this tension has what? The x and then the y component. Okay, so we have what? The x component to be in this direction, and then the y component to also be on this direction. So we are going to find the x and then the y component. So I'm in the x component tx and then the y component ty. Okay, so let's say you want to find the sine of the angle. The sine of the angle will be sine of what? 15 degrees equal to what? Opposite, right? So that will be what? Ty. tension in the y direction, and then over what, hypotenuse over t. So that give me ty to be equal to what, t sine of what, 15 degrees. Okay, so what of tx, that be cosine of what, 15 degrees will be equal to what, tx over what, t, right? So tx will be equal to what, t times what, cosine of what, 15 degrees. Okay, so for the first t, let's come and write down the component also. So for the first t, that's the tension, we have what, uh t cosine of what, 15, right? So that be t cosine of 15 degrees, that's for the x axis direction, so let's make it I. Okay, and then plus for the y also, we have what, t sine of what, 15 degrees, so that's t sine of 15 degrees j. Okay, so that's for the first t. Okay, that's the tension force. So we are going to do the same for the normal force also. Okay, so for the normal force, the angle it makes with the line of action of the weight, okay, is what, this 20 degrees here. Okay, the angle it makes here is what, this 20 degrees here. Okay, so let's see how they got that angle. So let's see, I have this system here. Okay, I'm going to draw another system on this. So let's say I have this one too here. Okay, so I'm going to bring this up here. Oh, it's actually selected this, that's not what I wanted. Okay, so let's do this. Okay, so I bring this here. Okay, so I'm going to rotate this in the anti-clockwise direction. Okay, so look at this. So let me rotate this here. So when I rotate this, look at what you have here. You realize that the angle here, okay, the angle I will have here will be the same as the angle I will have here. Same here, same here. Okay, so looking at this, let's see, when I draw a straight line through this point here, okay, you see that what you have this angle here, right? Same angle that we will have here. So this angle here is given to about 20 degrees, so the same angle that this side will also have what, as well, 20 degrees. So that's how can we have what, 20 degrees to be here. Okay, so now that you know how you got that angle, let's continue. So you know that the normal force to has what, the x and then the y component, right? So this will be the x component, and then the x component will have to move in the direction of the force, x component, and then this will be what, the y component. But I see that the x component will be negative since it is moving against what, the positive x axis direction. So the x component of the normal force will be what, negative. So if you want to find the x component, you see that what, it is opposite to this angle, right? So you see that what, sine of what, theta, which is what, 20 degrees, equals what, the opposite, which is rx over what, hypotenuse over r. So you can make rx the subject, and then this becomes what, r times sine of what, 20 degrees, same as the y component also. So it is adjacent, so you can see what, cosine of what, 20 degrees equals the adjacent, which is what, ry over what, hypotenuse, which is what, r. So then you have ry to also be equal to r times cosine of what, 20 degrees. Okay, so let's kind of write for the normal force also. So that one we have what, the s component. Okay, we know the s component will be negative since it is moving what, in the negative x-axis direction. So you are going to negate this. So this becomes what, negative r sine of what, 20 degrees. Okay, that's in the x-axis direction. So let's make it I. 20 degrees I. Okay, plus r cosine of what, 20 degrees. So plus r cosine of what, 20 degrees. Okay, so we've gotten the force acting on the scale. Okay, I want to find the tension force which will cause the scale to be in what, in equilibrium, or to move at a constant velocity. For us to do this, we have to equate all the s component and then the y component to 0, and then you solve for the missing ones. Okay, so you are going to add all the s components. So sum of forces in the s component. So in the s component we have what, T cosine of what? 15. T cosine of what? 15 degrees. And then minus what? R sine of what? 20 degrees. Okay, and this will be equal to what? 0. Okay, so we're going to do the same for the y component also. Okay, so that's some of the forces in the y-axis. So we have what? The weight. The weight is acting in the negative y-axis direction. Okay, the weight acts in the negative y-axis direction. So it will be what? Negative. So that's what? Minus 670 Newton. Okay, plus T sine of what? 15. T sine of 15 plus what? R cosine of what? Okay, there's supposed to be a J here. Okay, plus R cosine of what? 20 degrees. Okay, this should also be equal to what? 0. Okay, so now that we have the some of the forces in the x component and the y component, you see that what we have two equations here with two unknowns, so we can solve them simultaneously. So I'm going to do substitution here. Okay, so I'll consider the force in the x-axis direction, and then I'll make t the subject. Okay, so that's I'm going to change this cosine of 15 and then sine of 20 into decimal values. Okay, so cosine of 15 will be 0.966. Okay, so that will be 0.966 t. Okay, so 0.966 t. All right, then sine of 20. Sine of 20 is 0.342, so that will be minus 0.342 r. Okay, all right, this will be equal to 0, but I want to make t the subject, so I'll take this guy to the right hand side. So I have a 0.966 t equals what? 0.342 r. So I divide both sides by 0.966. So divide by 0.966. So I'll cancel out. So let's see what you have at the end. So that would be 0.342 divided by 0.966. So at the end I got my t to be equal to what? 0.354 r. So 0.354 r. So that's the value for what? T. Okay, so let me write this here. So t equals 0.354 r. Okay, so what I'll do next is that I'm going to substitute this value of what? T into the second equation. Okay, into the y component. Okay, so let's do this. So wherever we see t, we can substitute this into it. Okay, so I'm going to rewrite this. Okay, so this will be minus 670 plus what? T sine of what? 15. So let's change sine of 15 also. So sine of 15 will be 0.2588. So let me make it 0.259. So that will plus 0, that's 0.259 t. Okay, plus what? Our cosine of 20. So I'm going to change cosine of 20 to that's 0.9396. So that's 0.94. So that will be equal to 0.94. Okay, this should be equal to what? 0. Okay, so I know the value of t, so I'm going to substitute this into this. So that what? First of all, let me take this negative 670 to the right hand side. So that will be 0.259 t. Okay, plus 0.94 r should be equal to what? 670. Okay, so now let's continue. So I'm going to substitute the value of what? T into this. So that was 0.259 into bracket 0.354 r. 0.35, that's 0.354 r, right? Okay, plus what? 0.94 r. 0.94 r. This should be equal to what? 670. So let's add these two. Okay, so let's add these two. So I'm going to multiply these two and then add it to this. Okay, so that's 0.259 times 0.354. Okay, so that gives me 0.091686. So let me make it 0.092. So that gives me 0.092 r. Okay, plus what? 0.94 r. This should be equal to what? 670. So let's add these two. So 0.092 plus 0.94. This gave me 1.032. So 1.032 r, okay, equals what? 670. So let's divide both sides by what? 1.032. So divide by 1.032. So let's see what we get for r. So this will be equal to what? 670 divided by 1.032. Okay, so this gives me my r to be equal to what? 649 point what? 22. So let me make this to be equal to what? 600 what? 15 newton. So that's the value of what? R. But we've been asked to find out the force in the tower rope, which is the tension. Okay, so that's the main focus here. So now that you know the R value, okay, our main focus was to find out the tension T, okay, which is the force in the tow rope. So now that you know the R to be 650, we can go ahead and find for the what? The value of T using what? This equation that we have here. Okay, so let me go ahead and then clean up to get some space, then we finish with the question. Okay, so simplifying the question, we got what? T to be equal to what? 0.354 r, right? But now we know R to be what? Equal to what? 650. So let's come and substitute here. So that was 0.354 times what? 650. So let's see what that will give us. So that's 0.354 times 650. So that actually give me T to be equal to what? 230.1 newton. So this is the newton. Okay, so this is the force that is required in a tow rope, okay, to keep the scale out at a constant what? Velocity. So this is what we asked to solve.